In this section, we're looking at properties of parallelograms. So let's first define what a parallelogram is. It's a quadrilateral with two pairs of parallel sides. So here's a sketch, and you can see the notation for parallel, the little triangles on the sides indicating parallel sides. So let's define the following theorems here and make a sketch. The opposite sides theorem. If a quadrilateral is a parallelogram, then the opposite sides are congruent. So I'll make a parallelogram here and show that the opposite sides are congruent. The opposite angles theorem states if a quadrilateral is a parallelogram, then the opposite angles are congruent. So I'll make a sketch of a parallelogram, and we'll show that the angles here, opposite angles, are congruent. The consecutive angles theorem states if a quadrilateral is a parallelogram, then the consecutive angles are supplementary. So the consecutive angles are the angles next to each other, like consecutive numbers would be 1, 2, 3, 4. The consecutive angles are the ones that are right next to each other. So 40 plus 140 would be 180. All the consecutive angles here would be supplementary. The parallelogram diagonals theorem states if a quadrilateral is a parallelogram, then the diagonals bisect each other. So a diagonal is a segment that goes from one vertex to a non-adjacent vertex in this case, and they both bisect at their midpoints. Example 1, ABCD is a parallelogram. If the measure of angle A is 56, find the measure of the other three angles. So we know that the consecutive angles are supplementary, and we know that the opposite angles are congruent. So I can write these statements here. So I can solve for angle B by subtracting 56 to both sides, and I get 124. So A and C must be congruent, and B and D must be congruent. Example 2, find the values of x and y. Well, I know that the opposite sides of a parallelogram are congruent, so I can take these algebraic expressions and set them equal to each other. So I know that, let's take 6x minus 7 here is equal to 2x plus 9, and then the other pair would be y squared plus 3 equals 12. Now all I have to do is solve for the unknown variable in both of these, and then we're done. So I'm going to subtract 2x to both sides and add 7, and I get 4x equals 16. I have to undo multiply 4 by dividing it. I get x equals 4. And then for the other equation, I need to solve for y, so I first need to subtract 3, and then I need to undo squaring. So square rooting will be the inverse operation of squaring, and I get plus or minus 3. And we're done. Example 3, show that the diagonals of FGHJ bisect each other. So in this case, I need to find the midpoints of these diagonals, and if the midpoint for each one happens to be the same, that must mean that they bisect each other. So first let's find the midpoint of segment FH. So I use the midpoint formula, which is x1 plus x2 over 2 and y1 plus y2 over 2. I substitute my coordinates here for f and h, and I ended up getting 1 and 1/2. So x is 1 and y is 1/2. So we're going to do the same thing as we did for the previous one. We just substitute the coordinates in for j and g, and we end up also getting 1 and 1/2. So both of these segments have the same midpoint, therefore they bisect each other. Incidentally, this quadrilateral FGHJ would also be a parallelogram. Okay, example 4. SAND is a parallelogram, and SY equals 4x minus 11, and YN equals x plus 10. Solve for x. Well, the diagonals bisect each other because it's a parallelogram. Therefore, SY must be equal to YN. So we can substitute the algebraic expressions into this equation here, and then we can solve for x. So I'm going to subtract x to both sides and add 11 to both sides, and I get 3x equals 21. Divide both sides by 3, and I get x equals 7. Now I can check this by plugging in 7 into the original expression for x, and I end up getting 17 for both, which is my check. Okay, I hope this makes sense. Good luck with the practice set.